Hello Math Analysis students. In this video we are going to learn the first part of our information about the conic section known as an ellipse. There are four types of conic sections. There's a circle and an ellipse and a hyperbola and a parabola, as you can see in the animation that's on the screen right now. We talked about circles last time, and we will talk about ellipse today, and we will spend another day working on ellipses as well. Today we're going to get the basic information about it, and we're going to get into some more specifics in our next lesson and next video. Today we are going to graph an ellipse and write an equation in standard form. Okay, so an ellipse definition is a set of all points where the distance from the foci is constant. Okay, so set of all points in a plane. The distance from the foci are 2 points. These points are fixed. One is a focus, and the plural of it is the word foci. Okay, so we're going to learn more about the foci during our next lesson, but they are two fixed points. And for an ellipse, the sum of the distances from any point on the ellipse to those two fixed points called the foci is constant. Now, an ellipse is kind of like an oval, similar to a circle, but in a circle, you go the same distance horizontally as vertically in all directions. And with an ellipse, we're going to be moving a different amount horizontally than we are vertically. There's a major axis, which is the longer axis of symmetry, and the foci always lie on the major axis. And there's a minor axis, which is the shorter axis of symmetry. So in our first picture right here, this is a horizontal ellipse. The major axis is horizontal because we're going out more horizontally than vertically. And our second and third ellipses, these are vertical ellipses. Our major axis is vertical and our minor axis is horizontal on these. Okay, so the standard form of an ellipse is x minus h, the quantity squared, over a squared, plus the quantity y minus k squared over b squared equals 1. And a is always the larger number. And when that larger number is underneath our x term, then we get a horizontal ellipse. The center is h and k, just like we have been doing with circles, and we get a lot of other shapes and graphs. We talk about h and k being the center, so that should be familiar. And we find the foci by doing h plus c k and h minus c k. We're going to talk about foci next class, and there's a relationship between the a and the b and the c that we'll talk about next class. And our vertical ellipse is when we have the a squared is the bigger number. When that bigger number is underneath the y, then we get a vertical ellipse. Whereas this one up here, the bigger number is underneath the x, then we're going more distance horizontally, we get a horizontal ellipse. If the bigger number is under the y, then we're going further vertically, we get a vertical ellipse. Okay, so let's just get straight into practicing. We have this equation, x minus 3 squared over 25 plus y squared over 9 equals 1. I think I may have forgotten to mention that in the previous, the definition. It's always equal to 1. Always, always, always. So here in this example, our center is the point 3, 0. Because h is 3, and since there is nothing here with the y, that's y minus 0, so our k coordinate is 0. Since the bigger number is underneath our x, then our major axis is horizontal, and our minor axis is vertical. And the bigger number is 25, this is a squared, so our a value is 5, and the b value, b squared is 9, so that means b is 3. So how would we graph that? We would go to our center point, 3, 0, 2, 3, 0. And then once again, the number underneath our x is telling us how far we're moving horizontally, or left and right. The number underneath the y tells us how much we move vertically, up and down. So from our center point, we will move 5 to the left, 1, 2, 3, 4, 5. And 5 to the right, 1, 2, 3, 4, 5. And up and down we'll move 3. 1, 2, 3 units, and 1, 2, 3 units. And then we try to connect them and making a nice smooth curve. Kind of like an egg, an oval, a little bit like a football. Doesn't have to be perfect. Obviously mine is not. But just like with the circles, there should not be any corners. So if you've got any sharp angles, then you need to fix that. Okay, and there we go. We just graphed an ellipse. Let's try another one. Okay, now this one, pay attention. We have our y term is first. So, and our bigger numbers under our y, this is going to be a vertical ellipse. The center is still going to come from our h and our k. Just be careful because the h is always the one that's with the x term. The k is always with the y term. So our center here would be 1, negative 2. The major axis here is vertical, and the minor axis is horizontal. And our a squared is 16, so that means a is 4. B squared is 4, so that means b is 2. So to graph, we would go to our center point, which is at 1, negative 2, and figure out how much we're going left and right, how much we're going up and down. Looks like we're going up and down 4. 1, 2, 3, 4. And down 1, 2, 3, 4. We're going left and right 2. Left 2, right 2. And tricky part, trying to make it look like a nice smooth curve. Again, doesn't have to be perfect. Mine could have looked a little nicer, but it's good enough for what we're doing. The foci, we will talk about that in our next class and next video. Okay, now let's talk about writing an equation. To write an equation, we need to know the center, whether the major axis is horizontal or vertical, and what a and b are, and then we can put it into our equation. So the center of this ellipse, sometimes I like to draw in my major and minor axis. Here's my major axis. I'm putting it in blue, and I'm going to put my minor axis in green. Where they intersect, that is our center, which in this case is 0, 0. Center is 0, 0. Our major axis is horizontal. And I forgot to put it here, but let's note that our a value is 5 because we're moving left 5 and right 5 from center. And our minor axis is vertical, and our b value is 2. So when we write our equation, we would have x minus h squared and y minus k squared, but since our center is 0, 0, we're just going to have x squared and y squared. I always like to put in the x and the y first. And underneath the x, how much we're going left and right, our a value is 5, so a squared is 25. Underneath the y, how much we're moving vertically, b is 2, b squared is 4. And our equation equals 1. Don't forget the equals 1 on the other side. Okay, let's try another one. This one is a vertical ellipse. I'm going to just draw in my axes again. This is my horizontal is a minor axis here, and vertical is my major axis. The center is at the point 3, 2. The major axis is vertical, and that a value is 1, 2, 3, 4, 5. And our minor axis is horizontal, and our b value is 2. So when we write our equation, we'll put our x minus h, so that's an x minus 3 squared, and our y minus 2 squared. Underneath the x is our number that tells us how much we're moving horizontally, which is b is 2, so b squared is 4. Underneath the y, how much we're moving vertically, a is 5, so a squared is 25, and equals 1. And we'll talk about the foci on our next video. Now we're going to talk about how to write an ellipse equation in standard form. We completed the square with circles, and we're going to complete the square again for ellipses. With circles, we had to complete the square twice, once for the x term and once for the y term. the same situation here. We just have a little bit of an extra step we're going to have to take this time. But first, let's do what we started doing with our circles. Let's get our x's together, let's get our y's together, and let's get our constant on the other side. So we'll have an x squared minus 6x plus 4y squared minus 16y equals, we'll move that 9 over and it becomes a negative 9. Okay, now we are going to have to complete the square. And I'm going to have to do something with my y's. I want to come over here and look at that first. For x's, since our x squared term has a coefficient of 1, we don't need to do anything with that right now. But look at our y's right here. We've got a 4y squared minus 16y. So we want to look at our y separately. We want to pull out the greatest common factor. And that factor is 4. Once we pull out that common factor of 4, then we have y squared minus 4y plus blank for completing the square equals negative 9 plus blank, whatever we add for the x's, and then whatever we add for the y's right here. Okay, now we can complete the square. For our x terms, when we take half of this negative 6, we're going to get negative 3. And when we square that, we get 9. And if we add 9 to the left side, then we have to add 9 to the right side. Now for y's, when we took half of this negative 4, we're going to get negative 2. And when we square that, we're going to get 4. And whatever we add to the left side, we have to add to the right side. But be careful here, because we're not just adding 4. Because we have this GCF out here, see, this is not really just a y squared minus 4y plus 4. This is really, it's really 4 times y squared. 4 times negative 4. So we're really adding a 4 times 4, which is 16, to the left-hand side. So 16 is what we need to add to our right-hand side. Now we just rewrite our completing the square, our perfect square trinomials. So this is an x minus 3 squared plus our GCF is 4, don't forget the 4, and then we have y minus 2 squared equals, and over here on the right-hand side we have 16. Now, we're almost ready, but we know that for an equation of an ellipse, we need to have this right-hand side is equal to 1, and we shouldn't have a number out here in front of this y. So we want to get our right-hand side equal to 1. How do we get our right-hand side equal to 1? We divide by this constant. So we're going to divide by the 16, and we're going to divide everything on the left by it as well. Divide this x term by 16, divide this y term by 16. Then we have, finally, x minus 3 quantity squared over 16 plus, let's simplify this, 4 and this 16 gives us 1/4, so we'll have y minus 2 squared over 4 equals, on the right-hand side, 1. And there we go. We have our ellipse equation that we completed the square, and now we have it in standard form. Let's do one more of these. This time we have 4x squared plus y squared plus 40x plus 6y minus 35 equals 0. All right, let's get our x's together. We've got 4x squared plus 40x. Our y's, we've got y squared plus 6y. And when we move that negative 35 over to the other side, it's going to become positive 35. Okay, this time I don't need to do anything extra with my y's, but my x's, they have a GCF. So let's pull out that GCF of 4. Then we have an x squared plus 10x plus blank. We're going to have to complete the square, so leave that blank. And y squared plus 6y plus something. We're going to complete the square. And on the right-hand side, 35 plus, let's leave 2 blanks, something for whatever we add to the left-hand side with our x's, and something for what we add with our y's. Now let's complete the square. For our x's, when we take half of this 10, then we get 5. 5 squared makes 25. So whatever we add to the left-hand side, we have to add to the right-hand side. But remember, this isn't just 25, because this 4 has to be distributed to each of these. So this is really 4 times 25. We really just added 100 to the left side, so we need to add 100 to the right-hand side. And with our y's, we take half of the 6 and we get 3. 3 squared makes 9. We'll add 9 to the right-hand side. Now we'll rewrite as a perfect square trinomial. We had our 4, and x plus 5, quantity squared, plus, this is y plus 3, the quantity squared, equals, when we add 35 plus 100 plus 9, we get 144. So now we're done with completing the square. Our last step is we want to make that right-hand side equal to 1, so we need to divide everything by 144. Divide everything on the left by 144, the x term and the y term, and divide the right by 144. Then we want to simplify this fraction over here. This 4 goes into 144 36 times. So we have x plus 5, the quantity squared, over 36 plus the quantity y plus 3 squared over 144 equals 1. And I didn't mention it on the other one, but we could tell from this what would be the center. This particular one would be a vertical major axis, a vertical ellipse. On the previous one, since the bigger number was underneath the x, that would be a horizontal ellipse with a horizontal major axis. Okay, so on our next class and our next video, we will be discussing how to find the foci and how to write the equation when we have different information. All right, I'll see you then. Bye.